Okay, so this is the Bushveld experiment. You can see the list of the stations we have for this for the experiment. You see the name of the network here. It's ZT. The name, the description down here, and the starting and ending date of the experiment. These are the list, the names of the stations, and the data are stored in the IRIS DMC. IRIS is stands for Incorporated Research Institutions for Seismology. The DMC is Data Management Center, I guess. And this, yeah, so the name of the city where the stations were installed. You can see the latitude and longitude and elevation of the stations. If you can see those little R next to the thing, next to this data center, it means restricted. So the data are still restricted for now. It's not open. If you see the other network here, you will see A. It means available or open. So yeah, that's the difference. If you go to DOI, this is the, as Sue was asking the other day, it's the digital object identifier. If you open it, then you'll see more information about the network, like the description, who operated the network, the network names, okay, and then the citation here. Like this is the citation you should use when you put or when you process the data. I can show you, for example, in how do you cite properly in your thesis or your papers. Let me show quickly. Yeah, like here, you just add the network code and the DOI in the paper, and then the citation. All right, and then there is a map showing the location of the data. You see the Bushveld, the eastern limb, the western, and the red triangles are the stations. Okay. Next, there are a couple of packages that you can use to download the data from the IRIS DMC. There are like 4 of them here, but I'm going to show you today the latest one, the OBSPy-DMT. But you can get them by sending an email to this address. And there is a format that you have to do correctly, like this one. You're gonna send this kind of email to the address, and they will send you back the data later. The next one is called the SOD, the standing order of data. I'm not gonna talk about it because it's gonna take time. The other one is GeoWid, and yeah, the OBSPy-DMT. It's was written in Python. So in order to use it, you have to, well, you need to install Python 3 in your laptop or in your computer, and OBSPy to check if you have Python 3 in your laptop. You just check in your terminal, type Python 3. If you don't have error, then it means you have it. And then in your Python 3, you must install the package called OBSPy. So yeah, to check it, if you have OBSPy, then you just, yeah, you call it like this one, for example. If you don't have error with this line, then it means that you have OBSPy. All right. So now I'm gonna show you how to, yeah, to get the data. So for the, let me check something. Oh, sorry, package, OBSPy, yeah. This is OBSPy-DMT, just a second. Okay, OBSPy-DMT. So for OBSPy, you just need one line to download the data, like some kind of this. So to run it, you just put the line in the terminal and hit enter, then it will download your data. But you don't want to remember all of those lines every time you use the package. So like in my case, I created this shell script. So I just need to change the variables like the network code, the station code, the starting and ending date of the data I need to download. Like here, I'm just downloading the data in 2018 from October to December. And the length of the data is like 1.5 hour, the magnitude higher than 7, and the epicentral distance between 90 to 140 degrees. And the format of the data will be in SAC because in processing, for processing and seismology, people always use SAC. Yes, so this is the line how you call the OBSPy DMT to download the data. So first I'm going to show you how what happened when you don't have the access to the database. So yeah, just this line.
Fenitra, can I interrupt? Sorry. Would you be prepared to share that script with the students that they can?
Well, no, yeah, it's not a problem. Yeah, I can.
Thank you.
Yes.
I'll remember to get it from you and we can put it in the folder.
All right. So just to call the script, you just type bash because it's a bash shell. So just bash and call the name of the script and hit enter and just wait what happens. As you can see here, it creates the folder Rust because the station is Rust, and just wait. We have 6 events here between this period of time, and just wait a little bit what happened. I will. It's gonna take 30 seconds.
Maybe while it's busy doing that, Sue asked, are you running a dual boot computer or pure Linux?
It's Ubuntu Linux.
Okay.
Yes. So as you can see, it says no waveform because it happens when you don't have access to this database. So now I'm gonna show you what happened when they give you the password. So I'll just comment this line and open this one. They're the same, except I added these 2 other options where I added my Gmail address because this is the email I sent to Iris to be linked to the database, and the password here. The password is just a series of letters and numbers, something like this, but this is not my password, of course. But I'm not going to show it here. I've already put the password in this file. Then I'm just going to call this file here with a little bit of shell scripting. It's password.fen. All right.
Clever, Fenitra, clever.
Yeah. And then save it. Let me clear my terminal. Okay. Then run it again. Now we should have data normally. Still have the 6 events between this period of time. And now, as you can see, it says saving waveform down here. So it means that it is downloading the data now. So let's wait for like 30 seconds to 1 minute to see. We are now at 2 out of 6 events.
So everyone can see now why it's important to start getting used to Linux coding. Sue says, are all the events from auto picking?
Oh, there is no picking in this process. No, it just downloading the events, and they're already. We are downloading the event from the catalog of Iris, so they're already actual events. You don't have to pick. Yeah.
Okay.
4, 6, just a little bit more. My internet is a bit slow at home, so I'm sorry for that.
No problem.
6 to 6.
And then Fenitra, in terms of the start time of the record, of course, if the event's 10,000 kilometers away, the origin time will be different to the time at which it arrives at Rustenburg. When does your, I suppose, the window, your waveform start? What time does it?
Oh, I just cut from the length is 1 hour and a half. So I think it's 10 minutes before P. And yeah.
So is there a program that works out when it would expect to have the P wave arrival at your station, or does it just use the origin time of the event as the start?
The event, yes. We use the origin time of the event. Yeah.
So in 1.5 hours you'll get everything. That's the
that's the idea actually.
Yeah.
All right. So yeah, it's done now. If you open the folder, the Rust folder, you can see the list of the, 6 events. And you open one by one, you see those are the 3 components: east, north, and the vertical component. Let's try another one. You'll see, the same. But if you see, this one has 6 because it has 2 sampling frequency. The B1 is the 40 Hertz and the H1 is 100 Hertz. But the problem is we have the same name for all the files, so it's going to be a problem when you process the data. So that's why I made this shell scripts, this kind of simple shell script to rename and copy all of those SAC files outside the folders. So if you run it, then it will copy.
Can I ask a question, Fenitra? Why did the high sampling rate file, if I read it correctly, seem to be smaller than the other one? You know, one is a 36.6 KB, the other one is sort of 800. I just thought the high sampling rate would be a bigger file. You see the top 3 are 800K, and the next 3 are 36K. I don't expect that the higher sampling rate.
Yeah, that doesn't make any sense. Normally it should be bigger, but I'm not sure. Maybe there is something wrong with the station. I'm not sure, but I haven't checked it actually. But usually I use the 40 Hertz because because the 100 Hertz is usually it's a bigger file, so it takes time to process. And 40 Hertz is enough to do to do my processing. That's why I don't use it. All right, so now you have the data for this 1, 2, 3, 4. We have 4 events with the data. You can play with SAC to check, to play around with the data. For example, let me show you a little bit of SAC. Okay, SAC is not working. Just a little quick. There we go. All right, so you just call SAC and we show you the vertical components. Don't display them. It's my other screen. Let me put it here. All right, so those are your earthquakes. Let me show all of the point. QDP off. All right. So those are like your earthquakes. You can see the P arrivals, the S arrivals. You see the Rayleigh waves are like clear. Whereas, OBSPy DMT also is a very nice package. It will write all of the headers you need for the processing directly into the SAC files. For example, if you open this SAC file, if you read it and open, if you show the headers, it will give you all of the information you need for the processing, like the sampling period here. You can also have the event date and time, the station name, the station latitude, longitude, and elevation, the event latitude, longitude, and depth. You can also have the station names, network, and even the magnitude of the event. So, OBSPy DMT I think it's the best